Okay, 65. Equation of the tangent line where x is equal to 2. So when x is 2, we know that y is going to be 2 minus 1 is 1 cubed is 1. So there's my point. And to find the slope, I know that f prime of x is 3 times x minus 1 squared times 1, the derivative of the inside. So f prime at 2 is 3 times 2 minus 1 is 1 squared is 1, which is 3. So that's my slope. So my tangent line is y minus 1 equals 3 times x minus 2. 73. Oops. 73 says this. The derivative of y equals k of x is 2 when x is 1. What is the derivative of these? Okay. So, in other words, k prime of 1 is equal to 2. Okay, so that's what this tells me. The derivative is 2 when x is 1. So we want to figure out things like this. What is k of 2x? Or the derivative. K prime of 2x when x equals 1/2. Okay, well this is really saying, can you apply the definition of chain rule? Okay, so I know the definition, the derivative of this is k prime of 2x times the derivative of the inside. Alright, that is what I'm using is this. Y equals f of g of x. Then the derivative is f prime of g of x times g prime of x. Right, that's the definition. So this is what we want. Okay, we want to know what's the derivative at 2x when x is 2. I think, oops, sorry. Sorry. This is what we're trying to find. We're not looking at, I'm writing this incorrectly. We want the derivative of this whole thing. So this is kind of like, let me show you, write it like this. So if y equals k of 2x, this is just some function with a bunch of x's in it, then y prime would be k prime of 2x times the derivative of the inside, which is 2. Well, at x equal 1/2, we have y prime is k prime of, I plug in 1/2 into here, of 1 times 2, and we know what k prime of 1 is. That's 2. So that would be 4. Okay, let's look at b. K of x plus 1. We want the derivative of this guy when x is 0. Okay, so the derivative of this is the derivative of the outside function times the derivative of the inside function, which is 1. So when x is 0, we have this equals k prime of 1 times 1. And k prime of 1, they told us, is 2. Right up here, right? Okay, 73c, k of 1/4 x. K of 1/4 x when x equals 4. So I want the derivative of that guy at x equals 4. So that's going to be k prime of 1/4 x times the chain rule says the derivative of the inside at x equals 4. I'm going to have k prime of, of 1 times 1/4, which is, again, that is 2 times 1/4, which is 1/2. Okay, so we're really, this problem is really pushing you to think about this derivative, or this the definition of this, of what the chain rule says. It's one thing to do it, just to do the problems. It's another thing to really understand what it is saying. Okay, so 76 is the same type of problem. It says we want h of 4 if h of x is f of g of x. So we want h of 4. So that's f of g of 4. It's not a derivative of anything, it's just this composition, f of g of 4. So we look up and say g of 4 is 2. So that's f of 2. And f of 2 is 1. Okay, does that make sense? See how that works? It's working. So let's do b. That's a. B h prime of 4. And h is the same thing. So h prime of 4. So we want, trying to keep it so I can keep this on the same screen. So h prime of x is the derivative of that guy, which is f prime of g of x times g prime of x. Okay, so h prime of 4 is f prime of, what's g of 4? G of 4 is 2 times, what's g prime of 4? 6. And what's f prime of 2? See, they tell us all this information. So that's 5 times 6, or 30. Okay, so these guys are going to be exactly the same, except they just reversed the order between the g's and the f's, and then they did a quotient rule in here. I think you should be okay on that. And 77 we will do in class, because for some reason I cut that off and didn't notice it. And then we'll go on to the last two here in the last video.